Okay, let's give you guys some more practice. So if you draw these parametric equations, it would trace out this curve from here. So when t is 0, it will be this will be your starting point, and then as you increase t, the particle will move along here from minus minus 2 from minus root 2 to positive root 2. So we're going to revolve this 360 along the y-axis. So when you do this, it will trace out a 3D solid. Work out the surface area of this. So we don't care about the surface area, the flat top up here. Okay, so don't worry about the surface area of the flat top. Just work out the surface area of the side. Okay, so press pause and have a go. Okay, so to do this, remember this. A small change in, so we've seen this before, a small change in time. So a small change in time, combine it with this, will give you a small change in the actual distance of the actual path. So a small change in time would result in this distance being traveled from here to here. So once you've got that, you would need to revolve it 360. Well, you would need to times it with the circumference of the circle, 2 pi r. But r in this case is really the radius as time is moving along. Well, this distance here, the distance here is given by this. So you've got to put this into the r here. So a small change in time combined with this will result in a small change in the actual distance of the actual path. And then once you've got this, then you need to times this by 2 pi r. But r is this thing here. So we can put this into here. So t plus root 2. Okay, and well, combine the whole thing. The area will be you summing up everything. Okay, so start with the a small change in time. Combine it with this. That will give you your ds. That will give you this. And once you've got your ds, then you will need to times it with the circumference of the circle, which is 2 pi, and then r. Well, r is being this thing here. So you can put this into here, which is this thing here. Okay, so the surface area is given by this from here, from minus root 2 to positive root 2. So the surface area boils down to you evaluating this whole thing here. So when you come to integrate this, when looking at this, to work out the surface area, you still need to work out dx by dt. You still need to work out dy by dt. So our original parametric equations were given by these. So now if you want to find out dx by dt, so from here differentiate it, that will give you dx by dt equals 1. Okay, and then differentiate this, that will then give you t, differentiate this, that will then give you root 2. So now we know dy by dt, we now know dx by dt. So put this into here, and then put this into here. Don't forget, we've got to square it, So this whole thing here will then become this. So now it's just a matter of us evaluating this. So to integrate this, notice that this thing here is exactly the same as this thing here. So maybe we should make this to be our u. So let u be this thing here. Well, if u equals this thing here, then du equals dt. So now we can put this. Now we can put this into here, and then put the u into here. And because du equals dt, we can replace dt with the du here. Then this whole thing here will then become a lot simpler. It will then become this. So now it's a matter of integrating this. Oh, by the way, here we are integrating with respect to t, and we are integrating it from t being equal to minus root 2 to t being positive root 2. So when you make this substitution, you remember you're integrating from t equals negative root 2, so that would equate to us in the u realm. It would equate to u being equal to 0, because minus root 2 plus root 2, and then here we are integrating it to root 2. So put the root 2 into here. So that would be root 2 plus root 2. That would be 2 root 2. So us integrating it in the when we're integrating in the dt realm, we are integrating it to root 2. Well, put it into here. So that will mean that u would be equal to this. So we are integrating from u equals to 0 to u being equal to 2 root 2. So that's this bit here, and that's this bit here. Okay, so in the dt realm, we are integrating from t equals minus root 2 to t equals positive root 2. But then when we're in the du realm, we are integrating from 0 to 2 root 2. Well, anyway, it boils down to us integrating this. So notice that, imagine this as being in a bubble here. When you differentiate this bubble, it's going to give you this u here, and you've got a u out here. So to integrate this, reimagine this as reimagine this as this to the power of a half, because to the power of a half is square root. So just know that when you differentiate this bubble here, it will give you 2u, and this u matches up with what's out here. So to integrate this, concentrate on this bit here. So to integrate this, to integrate this, we are looking for something in such a way that when we differentiate it, it will then give us this whole thing here. Well, zoom into this bit here. We are searching for something that when we differentiate it, it will give us this thing here. So make this to be your initial guess, where this is one notch higher than this. So make this to be your initial guess. Well, if you make this to be your initial guess, if you differentiate it, it will then give you, this thing goes down, so that's this bit here. The bubble stays intact, and then this thing here gets minus by 1, and then you've got to times with the derivative of the bubble itself, which is 2u. So now negate this. So make the adjustment to the initial guess, 2 over 3. Now if you differentiate this, it will then give you this. Okay, so now you've got your 2 here. That's this 2 here. You've got your u here. And this is exactly the same as this. So the only thing that's missing is pi. So make the adjustment to your initial guess, pi. So you see, so now if you differentiate this, it will then give you this with a pi in there. So this now is exactly the same as this. Well, integrate this thing here, it will then give you this. It will then give you this thing here. Okay, so now put this into here, and then that will then give you this, and then put this into here. That will then give you this. So blah blah blah. The overall answer would be this. Okay.